Assalamu alaikum. My name is Riba Ismail, student of KIET, and I worked as a front-end developer on my final year project using React user interface.
Hello, I'm Basil Altaf, my student ID is 64921, and I'm responsible for geometric feature extraction, CNN, and making RESTful API using Django.
I'm Laiba Ishraf. I'm a front-end developer and accessibility lead.
Assalamu everyone, this is Ahmed, and I welcome you all to our final year project presentation video. In this video, we are going to tell you about how we achieved such an innovative and one-of-a-kind software using machine learning algorithms. But before that, I would like to thank to my university to giving us the chance to work on this innovative project. Furthermore, I would like to provide my heartfelt gratitude to our jury for giving us the opportunity to work on this project. Last but not the least, our advisor Sir Umar Qureshi for helping us throughout the development phases of this project.
So now we're going to see how we have actually achieved this innovative signature verification system, and for that we have actually used the pre-built model of CNN, that is VGG16, which was quite effective, but adding more robustness and more preciseness to the signature verification system, we have actually trained LSTM and Siamese models. And you can say, adding icing to the cake, we have used GLCM, which analyzes the texture patterns in the ink and what page have we used, what texture have been applied to the page. Moving forward, this is our system architecture in which we are using the React frontend, which is being powered by Django API at the backend, which then connects the data to the machine learning model, which is also connected to database, so that when one user just submits his signature, so his user ID gets checked in the database, and all the previous signatures that he's already provided in the database are being used as the reference of his actual signature. So his submitted signature and his reference signatures are both being compared, and if the submitted signature is actually the authentic one, then it gets added to the database. In the other case, it gets discarded and the signature is marked as forged. But the question is how we actually achieve that signature. So we actually capture the signature via two methods. You have option to capture from the camera. Your camera is always connected to your laptop. You could use phone camera or actual camera, or you can simply capture the image and upload into the system. And at whatever angle you capture the image, we have like built-in cam scanner similar approach, so that all signatures could be normalized and gets equal in size. Last but not the least, I have the machine learning algorithm workflow in which we are using CNN, RNN, and CMEs to get feature, stroke, and similarity respectively. After that, the feature score aggregation has been made, which is then being marked as genuine and forged, and the results are then shown in the front end. Now moving forward.
So first, user lands on our login page. Then after login in, we have two options: to drag and drop the image directly from PC or to capture it with IP camera. Here we are using IP camera to capture the signature images. IP camera will capture it and crop it and upload for verification. Now Labo will continue further.
So as we know that we captured the signature, now we click on verification signature, and then we will wait for machine learning algorithm for processing CNN features analysis, and final step take place so that the model tells the signature is forgery and have all discussed metrics that discussed before.
So when it comes to code, this is the front end of our React application. app.jsx is the file that is responsible for the authentication token when the website loads, and the camera capture.jxs is actually responsible for the capturing the camera live, and dashboard is responsible for obviously dashboard, and then login page, feedback animation, enhanced user profile selector, and then dashboard UI. Now when it comes to our backend, we have V is actually our folder for the virtual environment that we have created for the Django RESTful APIs, and then signature verification project is actually the folder that contains the settings for the whole project. That includes the cores, where the media files are supposed to be stored, the database, and all of that other stuff. And then when it comes to signature API, this is the main API that we are using to run the whole Django server. And under this utils, and then verification handler is actually the handler that is used to handle all of the verification requests. Preprocessing.py is actually the file that is used for pre-processing the files to make them black and white and apply all of the other features that we have put to remove the noise in the picture. Pre-processing module is the module that we are using for that, and then integrated signature verifier is actually the file that we use for verifying the signatures, and then combined signature verifier is actually the verifier that combines all of the signature verification methods that we use: CNN, CMEs, LSTM, and geometric and structural features. So this is the main file that actually extracts the feature from the files. So yeah.
Last but not the least, this is our FYP report that has all the literature, all the specifications, and all the diagrams that you need to understand the working of this project. We hope to see you soon. Allah Hafiz.